Welcome back. We now have a complete, living neural network with layers, neurons, and activation functions. But we're missing the most important piece of the puzzle. How does it actually learn? How does it go from making random guesses to making highly accurate predictions? Today, we unveil the single most important algorithm in deep learning, the magic of backpropagation. When we first create a neural network, all of its millions of weights are initialized with small, random numbers. As you can imagine, this means its initial predictions are completely useless. The entire goal of the process we call training or learning is to systematically and intelligently adjust all of these weights to minimize the error. We need a way to measure this error, and for that, we use a loss function. It takes the network's prediction, compares it to the correct answer, and spits out a single number representing how wrong the network was. The entire learning process is a continuous loop that can be broken down into 4 distinct steps. First, the forward pass, where we feed data into the network and it generates a prediction. Second, calculate loss, where we measure the error of that prediction. Third, the backward pass, also known as backpropagation, where the error is sent backward through the network to assign blame to each weight. And fourth, update weights, where we make tiny adjustments to all the weights to improve the prediction for the next time. This cycle repeats, sometimes millions of times. Let's walk through the first 2 steps. This is the easy part. We take a single piece of data, like an image of a cat, and feed it into the input layer. The information flows forward, from layer to layer, with each neuron performing its weighted sum and activation. Finally, the output layer gives us a prediction. Let's say it predicts 80% dog, 20% cat. Since we know the true label is 100% cat, we can use our loss function to calculate a score, a single number that quantifies exactly how wrong that prediction was. Now for the magic. Step 3, backpropagation. This is the algorithm that made modern deep learning possible. It is, in essence, an incredibly clever way of assigning blame. Starting with the final loss score, it uses the chain rule from calculus to propagate the error backward through the network, from the output layer all the way to the input layer. As it does this, it calculates the gradient for every single weight. A gradient is a vector that tells us exactly how much that specific weight contributed to the total error. It's the key to knowing how to fix our mistakes. Once backpropagation has done its job and given us the gradient for every weight, we move to the final step, updating the weights using an algorithm called gradient descent. The logic is simple. If a weight's gradient tells us that increasing this weight increases the error, we do the opposite, we decrease the weight slightly. The size of this slight adjustment is controlled by a crucial hyperparameter called the learning rate. By repeating this cycle thousands of times, the network takes tiny steps, slowly descending the landscape of error until it finds a minimum point, where its predictions are as accurate as possible. And that is the engine of deep learning. This 4-step loop, forward pass, loss calculation, backpropagation, and weight update, is the fundamental process that enables a network to learn from data. It's a beautiful application of calculus and optimization that allows a massive, complex system to systematically improve itself. We now understand the full picture of how a single network learns. But what makes a network deep? In our next lesson, we'll finally define deep learning and understand why more layers means more power.